You know, every single time you visit a website or shoot off an email or use pretty much any app, you are leaning on a piece of internet tech that was built all the way back in 1985. But what if I told you that system was built with a massive, massive security blind spot, one that basically leaves your digital footprint totally exposed? Well, today we're diving into that exact open secret and the huge effort that's underway to finally fix it. So here's our game plan. First, we're going to get to know the internet's hidden phone book, DNS. Then, we'll expose its open postcard problem. After that, we'll check out two really clever solutions. One is kind of like a wax seal for authenticity, and the other is like a secure envelope for privacy. And to wrap it all up, we'll jump into the big debate this has started about privacy versus control online. All right, first up, the unseen phone book. See, to really get why there's a security problem, we first have to understand the system that pretty much makes the entire internet, well, work. The domain name system, or DNS, is almost always called the phone book of the internet. And it's a perfect analogy. We humans, we remember names, right? Like example.com. But computers, they need numbers, these things called IP addresses, to find each other on the network. DNS has been doing that critical translation job since 1985. And let me be clear, without it, the web as we know it just wouldn't exist. So, how does that lookup actually work? Well, it's a little journey that happens in a flash. You type in a web address, your computer then sends that request to something called a recursive resolver. Just think of it as a super helpful librarian. This librarian first asks a root server, kind of the main index for the whole internet, where to go. The root server points to the right section, say the .com server. That server then points to the specific server for that domain, the one that holds the final record. And bingo, that server gives the librarian the exact IP address, which it then hands back to your browser. And all of this happens in milliseconds. It's incredible. But here's the catch. For decades, that entire multi-step conversation has been happening completely out in the open. And this brings us to section 2, the open postcard problem. You see, old-school DNS queries are sent in plain text. That means zero encryption. Honestly, the best way to picture this is to imagine that every time you look up a website, you're not sending a sealed letter. Oh no, you're sending a postcard. And anyone who handles that postcard along the way can read exactly what's on it. And this creates some pretty serious risks. First, simple eavesdropping. Your internet service provider, the admin on your coffee shop's Wi-Fi, or an attacker, they can all see every single site you visit. Then you've got DNS spoofing. This is where an attacker forges a postcard with a fake address to trick your computer into going to a malicious site. And finally, there are man-in-the-middle attacks, where someone literally intercepts your postcard and changes the address before it even gets back to you. So, how do we fix this mess? Well, the first part of the solution showed up looking a lot like a digital seal of approval, which brings us to section 3, the wax seal and the introduction of DNSSEC. DNSSEC stands for Domain Name System Security Extensions, and its whole job is to add a cryptographic digital signature to DNS responses. Just think of it like a wax seal on an old-timey letter. The seal doesn't hide what's written inside, but it proves without a doubt that the letter came from the right person and that nobody messed with it in transit. It's all about authenticity. Now, this next part is absolutely crucial to understand. What DNSSEC does versus what it doesn't do. It authenticates the data, right? It verifies the source is legit, but, and this is a big but, it does not encrypt the data. Your postcard is now verifiably from the right person, but it's still a postcard. Anyone on the network can still see you're looking up example.com. So we've solved the tampering problem, but not the privacy problem. And that brings us to the second, much more recent solution, the one that tackles privacy head-on. Let's talk about section 4, the secure envelope, and DNS over HTTPS. Or just DOCH. Okay, so what DNS does is pretty clever. It takes your DNS query and wraps it up in the same standard HTTPS encryption. That's the little S that secures your connection when you're on your banking website. So instead of sending that open postcard, we are finally putting that request inside a sealed, totally opaque envelope. Now no one can see the destination written inside. So let's break this down. DOH encrypts the data. It does a fantastic job of hiding your browsing history from your ISP or anyone else snooping on the network. But by itself, it doesn't actually authenticate the source of the response. The envelope is sealed, which is great, but how do you know the reply inside is really trustworthy? And this is why DNSSEC and DOH are such a power couple. You get the sealed envelope of DOH, and inside is the wax-sealed letter of DNSSEC. And when you look at them side by side, the technical shift is just night and day. With traditional DNS, you have absolutely no encryption, super low privacy, and it all happens on a really obvious, easy-to-spot port. With DoE, you get full encryption, high privacy, and the best part is it just blends in with all your other normal, secure web traffic, which makes it way harder for anyone to single out your DNS requests. But you knew there was a but coming, right? This transition hasn't exactly been smooth sailing. Encrypting such a fundamental part of the internet has kicked off a major debate. And that brings us to our final section, the Great DNS Debate. The controversy really boils down to three core issues. First, since DOH can bypass the old ways of network monitoring, it messes with things like parental controls and corporate security filters. Second, there are these big centralization concerns. Instead of your local ISP handling your DNS, your requests are now going to just a few massive tech companies like Google or Cloudflare. And third, that same encryption that protects your privacy can also be used by malware to hide its tracks from the very security tools trying to protect you. This whole thing got so heated that a trade group for UK internet service providers actually nominated Mozilla, the makers of Firefox, for an Internet Villain Award. I'm not kidding. Their argument was that by turning on DOH, Mozilla was making it way too easy for people to bypass the web filtering systems they were legally required to provide. Mozilla, for their part, was pretty much just shocked. They basically said, whoa, hold on a second. We're not being villains. We're just applying a long overdue security upgrade to a piece of internet infrastructure that's been broken for decades. And right there, that's the core tension. Some see DNS as a point of control, and others see it as a pathway to privacy. And it's not just a fight between browsers and ISPs. Even the NSA has weighed in on this. They've actually warned big companies against using these external DoE services, arguing that it stops them from being able to inspect their own network traffic to hunt for threats. It essentially blinds their own security teams. Now, you might be thinking this is all some niche techie debate, but it's really not. This shift is already here. Back in 2020, browsers like Firefox and Chrome just started switching DOH on by default for millions and millions of users. So odds are your browser is probably using it right this second. So after all that, let's bring it home. What does this all mean for you? Well, first, your online privacy has probably gotten a huge boost, since your browsing history is now likely shielded from your ISP. Second, DNSSEC is quietly working in the background to add that layer of trust, protecting you from being sent to fake sites. And finally, and this is the most important takeaway, these two technologies aren't rivals, they're partners. Together, they give you both authenticity and privacy, a secure foundation for the modern web. So, this fundamental rewrite of the internet's phone book is forcing all of us to ask some really big questions about security, about privacy, and about control. The technology now exists to have both authenticity and privacy. The real question is, as we build this next version of the internet, what are we actually going to choose to prioritize?